All right, so let's quickly talk about our last type of hybridization that we're going to discuss today, which is sp hybridization. So sp hybridization comes now from when we're combining an s orbital now with only one p orbital. So let's take a look at this with carbon. And if we hybridize these orbitals in carbon, what we end up with is having two hybrid orbitals, and then we're going to be left with two of our p orbitals that are each going to have an electron associated in them. So again, looking at the shapes, now we're just combining two. We've got these two equal hybrid orbitals plus these two p orbitals here. So let's take the case of acetylene, where we have two carbon atoms that are going to be triple bonded to each other. Each are bonded to a carbon and then to one hydrogen. So this is a little bit trickier to look at and see what it means, but essentially we have two hybrid orbitals, which are shown in blue here, and then we have one p orbital that's left alone that's going up and down on the page, and then that second p orbital is actually coming right out at you. It's coming out of the screen at you. So if we think about this Z bonding axis between the two carbon atoms, we can picture overlap of those sp hybrid orbitals. And then we can also picture bonding to hydrogen. So in acetylene, what is the bond angle here? This is the easiest question all day. What is the bond angle between all of these? Yep, great. So it's 180 degrees. So if we think about the bonds that are forming, oh, I see our TAs are here. So you can start handing them out because we still have 2 minutes left to go. So this way there's not chaos as you leave. All right. So as they're very quietly handing out your class notes, let's think about what this bond is here. This boxed bond, is it a pi bond or a sigma bond? It's going to be a sigma bond. So we have sigma 2sp, carbon 2sp. So they're two sp bonds combining. Now let's think about this first pi bond, which will be above and below the bonding axis. Is this pi or sigma? This is pi. So we're talking about pi carbon 2px, because it's the x-axis combining, to carbon 2px. And the last bond that we have here is a carbon-carbon bond. And this is our last p orbitals that are coming together. These are the ones that are coming right out at you. So this is going to be a second pi orbital. So this will be pi carbon 2py, carbon 2py.